Alright, make sure you have your factoring special cases sheet out in front of you. This is where we're going to talk about special cases with factoring, and really the special cases come along when we're talking about perfect squares. So at the top of your paper, we're going to list off some perfect squares. Alright? So like 1 squared is 1, 2 squared is 4, right? 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared 81, and let's just do a couple more. 10 squared is 100, 11 squared is 121, 12 squared is 144. So those are most of the ones that you'll need to know, but we just want to talk real quickly about these perfect squares and how we can deal with these when we're factoring. So it says right here, circle all the trinomials that are perfect square trinomial. Then the middle number is twice the square root of AC. So when we look at this, the square root of 1 is 1. The square root of 9 is 3. Alright, and 1 times 3 is 3. So twice that would be 6. So this is a perfect square trinomial. Alright, 1, square root of 1 is 1. Square root of 25 is 5. 1 times 5 is 5. But 2, twice that, is 10. So this is also a perfect square trinomial. Let's look at number 3. Number 3, 1 squared is 1. 5 squared is 25. So 1 times 5 is 5. And twice that is 10, not 26. So I'm going to just draw a line not through that one. Okay? 1 squared is 1. 6 squared, so 1 times 6 is 6 times 2 is 12, not 13. Right? Number 5. Right? I'll have you go through and do the rest of these, and then you can kind of pause it, and then we'll talk about actually factoring one. Alright, so hopefully you've paused it and you've gone through and you circle all the ones that are perfect square trinomials. And now we can kind of look here. Let's look at this first one. If you want to use the box method, you can. And then you'd put the x squared here, you'd put the 9 here, and you'd go, alright, I have to have two numbers that are multiplied together to give me 9. But think about it like this. The numbers you multiply together to give you 9 are going to have to be the same numbers. Alright? Because they're going to add together to give you 6. So it's going to be 3 and 3. 3x, 3x. And then this would factor then to give you x plus 3 times x plus 3. Alright? This is going to give you a perfect square trinomial. X squared 6x plus 9. Because it's x plus 3 times x plus 3. If we had x plus 4 times x plus 4, that will also give you a perfect square trinomial. Alright? So that's the perfect square ones. Finish that up, and then I want you to answer these two questions at the bottom. But we are going to talk about the back for a minute as well. On the back, you want to remember those numbers, but I want you to look specifically at number 1. So if we look at number 1, it says kind of some of this in the directions, but I want to kind of walk you through it. So here's what I want you to think about. In number 1 here, you have to find two numbers that are going to multiply together to give you -4, but that are going to add together to give you 0. The only two numbers that will ever add to give you 0 are opposite numbers. So if you think about opposites, let's write some opposites at the top. Like -2 plus 2 is going to be 0. 3 plus -3 is going to give you 0. 4 plus -4 is going to give you 0. I mean, we could go on and on and on with that, right? But so what we're looking at here is we have to figure out what numbers we can multiply here that are going to give us -4 but give us 0, and they're going to have to be the same number. So just take off this negative and just think about 4. What two numbers do you multiply by to get 4 that are the same number? 2 and 2. So here we're not looking at 2 and 2, we're looking at -2 and +2. And if you look, you've got x minus 2 times x plus 2. And this is what's called the difference of squares, right? So we will get rid of that middle term every single time. This is another special case polynomial. Let's try one that's a little bit bigger. Let's try like number 17. You notice